Bismillahirrahmanirrahim. I welcome all the engineering students of engineering dynamics, and especially the students of Khwaja Farid University of Engineering Information Technology. Dear students, in the previous lecture, we have studied the relative motion, and we already discussed the rectilinear motion, curvilinear motion, different coordinates like NT, R, theta, and space coordinates. The last topic of this chapter number 2, which is very important, that is constraint motion. Constraint motion means, or we can say the motion of the connecting particles, means the bodies are connected with each other to some rope or chain, and their motion is restricted due to the construction or the working. If you see here the body A is sliding on this horizontal surface and body B is hanging vertically. Of course, this pulley moves from this point to this point, right? It can move from here to here only, and it cannot move beyond this, so it is constrained, right? Similarly, body A can move from this pulley to a maximum to a certain length, which depends upon the length of the changing length of the rope. So this is called the constraint motion. We will study the constraint motion. It may be a 1 degree of freedom, it may be a 2 degree of freedom, it may be a 3 degree of freedom. Remember that the degree of freedom depends upon the number of ropes connected. If you see in this case, it's a 1 degree of freedom. If I say this is the rope, it is moving over this pulley and then it's wrapped around this second pulley and then attach here. There's only one rope which is moving, therefore it's a 1 degree of freedom. Right? So I defined the motion of this distance. I say it's x, of course, and I say the motion of this pulley is y, and this distance b is basically a constant distance. And there is a certain amount of rope which is constant wrapped over the two pulleys. So if we define the total length, so length will be is equal to x, of course, x, right? Then amount which is wrapped over this, if I say it's a half of it will be wrapped, it is pi r2 by 2 plus 2y, because there are two ropes, so 2y, right? So plus pi r1, s is equal to r theta, plus this distance b. If you see here, b, r1 and r2 are basically constants. So if I took the first derivative, so L is constant, of course, the length of the rope is not changing with respect to time. So X is changing with respect to X dot. This is constant, pi r2 by 2. Y is changing, is 2y dot, pi r1 and plus b is constant, is 0. So it is X dot plus 2y dot, or I can say 0 is equal to VA plus 2VB. Or I can say VA is minus 2 VB and vice versa. Similarly, if it is the second derivative, x dot plus 2y dot, double dot, we get 0, acceleration of A plus 2 times acceleration of B. It means acceleration of A is equal to 2 times of acceleration of B, but in the opposite direction. So, the velocities and acceleration of the two bodies are related with each other and they are in opposite direction. So this is I've shown you the example of a single degree of freedom. Okay, 1 degree of freedom systems, applying the infinitely small a is lower pulley. So I use the same, in this example, it means you just take the length, and once you take the derivative, the constants are 0. So it means I can also take simply x plus 2y plus constants is equal to L, and I can already say that x dot plus 2y dot is equal to 0, and from here I can find the velocities and acceleration. Next, we move to the 2 degree of freedom. I call this system as a 2 degree of freedom because here there are two ropes. If you see this cylinder A is attached, the first rope is attached with cylinder A, passing over from this pulley, then the pulley D, and then attached to the fixed point. This is one rope. The second rope attached at the center of the pulley D, then wrap over this C, then wrap over this pulley, and then attach with the cylinder B. So dear students, now your concept and your visualization in these type of cases is you have to visualize which lengths are to be varied. Of course, B is moving from here to here, I say it's YB. A is moving from here to here, I say YA. This pulley from this point to this point can move up to here, that can have YD. Similarly, this C pulley, this C, I say it is YC from here, this pulley to this pulley, right? So, let's write the lengths of the two pulleys LA and LB, and then by taking the derivatives, first derivative and the second derivatives, we can find the velocities. So, if you see LA, if I say it's LA, this is, I'm taking the first row of this one. So LA is equal to YA plus this times 2. This is constant because pulley cannot move beyond this. So these 2 points, these 2 lengths is 2YD is equal to constant. Similarly, I write the LB, this length. So LB is YB plus YC plus YB plus YC plus this distance, right? So this distance is YC minus YD. So we get this length of the rope. I again repeat, this YB plus YC plus this length, which is YC minus YD. Plus some constants, of course, the constant length of the length is not changing and the length wrap over the pulleys. So taking the first derivative, we get y dot of A plus 2y dot of D is equal to 0. And then we take the second, the derivative of the second equation, y dot of B plus y2, this yc plus yc with 2y dot of C minus y dot of D. And taking the second derivative, the y double dot of A plus 2y double dot of D. And similarly, y double dot of B plus 2y double dot of C minus y double dot of D. And then we have to eliminate, because this D is the intermediate pulley, we remove the y dot D and y double dot D from these equations. So I can find the value of y dot from here, D, and put in this equation. So I will get the velocity of A plus 2 times the velocity of B plus 2 times the velocity of C, because the bodies are this A, B and C. Similarly, the acceleration of A plus 2 times the acceleration of B plus 4 times the acceleration of C is equal to 0. So if A and B have downward, if A and B are moving downward, if this one is positive, then of course C will be negative. If I say the upward movement is positive, then the motion of A and B will be negative. These are the equations, so we can find out the velocities of A, B and C relative to each other. Dear students, let's move to this simple problem 2-15. Here, the visualization, and you have to find out which length is to be changing. That is more important. And to write the length equation of the length of the pulley, and then taking the first and second derivative, you can easily find out the unknowns what you required. In the pulley configuration shown below, cylinder A has a downward velocity of 0.3 meter per second. Determine the velocity of B. Solve in 2 ways. Anyhow, if you see, if I say this pulley, this length is changing YA, and this length is of course changing, see, YB. See, this one is, I say YB, and of course this length is again fixed. This length of this length of the rope is also fixed. So we have given that the body A is moving downward, therefore body B is moving upward. If I take downward positive, then B, velocity of B should be positive. It is automatically comes when we write the equations. So L is equal to, if I say L is equal to, see, 3, 1, 2, 3. I can also take only this distance, right? If you want to take, we can take only C, because this is a rigid body. So I can say 3YB plus 2YA, 3Y plus constants, right? So if you take the first derivative, because 3VB plus 2VA is equal to 0, VA is 0.3, put the value of VA, you get the value of the velocity B, which is minus 0.2 meter per second, because as we are taking downward velocity positive, upward velocity is negative. This is the only requirement in this question. Okay, second method. For you people, for the sake of those students who really wants to go inside this, therefore I'm showing you this second method. It is little bit difficult, but let's see. The large diagram of pulley A and B and C is shown, right? So I have shown you the pulley A and B in large diagrams. During a differential movement, DSA, of the center of the pulley A, The left end has no motion. It is attached to the fixed part of the cable. Forming the geometry, if you see the small movement, it is 2DSA is equal to 3DSB. 2DSA is equal to 3DSB, right? Why? 1, 2 and 3. So DSB is 2 by 3 DSA and VB is equal to 2 by 3 VA. We get the 0.2 meter per second. I prefer the first method, and that is more easy and more understandable to you. It is the movement of the pulley relative to other. If this move 2 DSA, then this DB and this DB 3 times, right? Therefore, it's 3 DC. Clear? So next one is the separate problem 2-15. A tractor A is used to hoist the cable B with the pulley arrangement shown. If A has a forward velocity VA, determine the expression for the upward velocity VB of the bale in terms of A. The tractor is moving along this horizontal direction. How the bale is moving, right? At any instant, its height is Y, and this is H, and this length is L, right? So it is only one rope. This is 1 degree of freedom, like in previous cases. So from the figure, it is very clear. So L is equal to 2H minus Y, right? Plus L, right? This will be equal to 2H minus Y. L in terms of H and this, right? This is L square, X square plus H square. So we have this equation. Now differentiate with respect to T. Remember that both Y and X are changing with respect to time. So L is equal to 0, H is constant, derivative Y is equal to Y dot, plus L is equal to 0. So this should be plus a derivative of this one, half H square plus S square minus half. The derivative of X is 0. First I take the derivative with respect to power, then function. So 2X and X dot. X dot is the velocity of VA, the tractor. The Y dot is the velocity of B with the bale. And just rearrange, put the values this, rearrange, we get this. VB is equal to X over 2 under root H square plus X square. VA, this is the velocity of B with reference to A, or with, because we know the velocity, we only need to find the velocity of B. If I know the VB and X, we can find the velocity of a bale. Okay, sample problem 2-207. If a block B has a leftward velocity, this one is a leftward velocity, towards this, is 1.2 meter per second. If it is moving leftward, it means A is moving downward. Determine the velocity of cylinder B. So dear students, you can really see that this length, I can take one of this length is 3 times and this length is 1 time, and then I write the equation. You see, let's see, I make this one. This is SB, and I say, because this pulley cannot move beyond it, this is SA. So 3SA plus SB is equal to, I take the derivative, 3VA plus VB is equal to 0. From here, VA is equal to minus VB by 3. You know the value of minus 1 per 2. I take left one is negative. If you take this one, left one is positive, then the VA is positive, and vice versa. So this is minus 1.2 by 3. It's VA is equal to minus 0.4 meter per second, which is a downward velocity. Let's see the next problem. Determine the constraint, problem 2-10. Determine the constraint equation. Determine the constraint equation which relates the acceleration of body A and B. Assume that the upper surface of A remains horizontal. This surface is not fixed. And then, if you see here, there is only one rope. This passes over here, here. These ropes are fixed, right? So there is only one rope. So it's a 1 degree of freedom. If you count this one, 1, 2, 3, 4, 5, 6, and 7, and this one is this. I can taste. If you see it, I have shown you here. Simple 7 SA plus SB is equal to L, 7 VA plus VB is equal to taking the first derivative, and second derivative to acceleration, 7 AA plus AB is equal to 0, AB is equal to minus 7 of AA. The acceleration of B is 7 times of the acceleration of A, but in the opposite direction. If you know the acceleration A, you can find the acceleration of B, and vice versa. Let's see the problem 2-209. Cylinder B has a downward velocity in feet per second given by VB is equal to T square by 2 plus T cube by 6, where T is in seconds. calculate the acceleration of A when t is equal to 2 seconds. We are given the velocity of B in terms of time. We need to find the velocity and acceleration of A. Again, this is a constrained motion. Only the velocity is given you in terms of time. If you take the acceleration derivative, you get the acceleration of B. So we have one velocity and velocity of B, one of the body, and acceleration of the one of the body in terms of time t, and then by using the again constrained motion equation, writing the equation for the lengths, we can find out the acceleration and velocity of body A. Now let's see, I have made the diagrams. Please remember that the free body diagram is very important, and selection of SA is very important. As you see which length is going to vary. If I say this length is going to vary SB, and this length is also going to vary SA. So VB is equal to t square by 2 or t cube by 6. So A at t is equal to 2 seconds. So AB. So AB, I take the derivative of t plus t, of course 2t over 2 plus 3t square by 6. We get t plus t square by 2. If I write this equation, is 1, 2, 3, 4, 4 SB, SA please. 2 SB plus the constant is equal to 0. Taking the first derivative, 4 VA plus 2 VB is equal to 0. 4 AA plus 2 AB is equal to 0. The acceleration of B by putting the value of t is equal to 2 seconds, because at that point we need to find the acceleration. It becomes 4 meter per second square, right? This is the 4 meter per second square. And now I put this value in this equation. 4 AA is equal to minus of 2AB, and this AA is equal to minus 2 meter per second square. Similarly, velocity of B at 2 seconds, so putting this value, I get 3.33 meter per second. And the velocity of A, from here you can find out, it's minus 2 VB upon 4, so minus 1 by 2, 3.33, you get minus 1.667 meters per second in the opposite direction of the velocity of B. Let's see another problem 2-221. Determine the vertical rise h of the load W during 5 seconds if the hosting drum, this is the hosting drum, wraps cable around it at a constant rate of 320 millimeter per second. So what is the height it got in 5 seconds, this weight W, if its wrapping speed is 320 millimeter per second? Dear students, you have to make the free body diagram. This is by motor. Let's see a small particle, small point A. I need to find out how this particle is moving. So I take this distance is SA. This distance is SA, right? Now this pulley is also moving. I say this is SB. And this is the movement, because weight can move from here to here maximum. I cannot be on this. I say distance of the W. So I write the equation. If you see here, two ropes, one rope is this one and the other rope is this one, so hence it's a 2 degree of freedom. So I write the equation for the L1. I say this rope is L1. I say SA, right, plus this is 2 SB, 1 and 2, because this is the distance which this pulley can move. 2 SB, equation number 1. Similarly, L2, this is my L2, is this is a if you see, it is from here to here, right? So it is SW, right? It is SW, if I say this SW plus SW minus SB, SW minus SB, right? So this is total SW minus SB. I can find out this equation, right? So SW plus SW minus SB. So if I take the L2 to 2SW, the same thing, 2SW, you can write this one, take minus SB, this distance cannot move, is equation number 2. Now, if you take the derivatives of this, 2VW minus VB is equal to 0, VA plus 2VB is equal to 0. Here, I cancel out the B, because intermediate velocity component here, because we are trying to find out the relationship between A and W. So 4VW plus VA is equal to 0. VA is equal to minus 4VW. So it is minus VW is equal to minus 1 by 4 VA. VA is 320 millimeter per second. So VB is equal to minus 1 by 4, 320 minus 80 millimeter per second. The height it travels, the velocity, the height traveled by the weight is simple. It's the velocity of, this is the velocity of W. Velocity of W times T, it got minus 400 millimeter in the upward direction because I take the velocity of A positive in the downward direction. Problem 2-212, a truck equipped with a power winch on its front and pulls itself up a steep incline with the cable and pulley arrangement shown. If the cable is wound up on the drum at the constant rate of 40 millimeter per second, how long does it take for the truck to move 4 meter up the incline? This is the this dotted line is shown that this is a long cable, and this truck is pulling to the winch, right? So it's a very simple question because this is the pulley, right, a double cable. If you see, a length of this one is 400 millimeter velocity. If the cable is wound at the rate of, this cable is wound at the winch as a 40 millimeter per second the velocity. So total length is 2L. L dot is equal to 40 millimeter per second. So L dot is equal to 2L dot. So the velocity of a truck is, so L dot is equal to 1 by 2 L dot. 1 by 2, 40 is 20 millimeter per second. So very simple. So time taken S by V. The question is how much time it take to wrap the cable, right, up to 4 meters. So 4 exponent T is millimeter. 20 meter per second is the velocity. It takes 200 seconds or 3 minutes 20 seconds to wrap up. Next problem is 2-213. For the pulley system shown, each of the cables at A and B is given a velocity of 2 meter per second in the direction of the arrow. They are moving in the opposite direction, right? They are moving in this opposite direction, right? Determine the upward velocity V of the load M. Again, you see here there are two ropes. One is this, and the second one is this rope, which is A and B. So it's a 2 degree of freedom system. Let's see the students. It's a slightly different question. Let's see. This I say movement is x1. This movement of B is x2. And if you see the figure, this is y1, which can move in the upward direction, and this is the distance, which is y2 minus is y2 minus y1, and this is y2. This is the body to move. Let's see. Velocity of B is 2 meter per second. So velocity of A is also 2 meter per second. This is given to us. So let's write the equation. So one equation is very simple. Okay, write the x1, right? X1 plus 2y, because for this rope, this the movement, x1 plus 2y1 is equal to constant. X1 dot plus 2y1 dot is equal to constant. Y1 dot is equal to minus half x1 dot 1 dot. First equation, that is equation number 1. Now this rope, so it's x2, right? This is plus y2 plus this rope, which is y2 minus y1. So x2 dot plus 2y dot minus y1 dot is equal to 0. So y2 dot is equal to y1 dot by 2 minus x2 dot by 2. So y2 dot is equal to minus, because I can put y1 dot is x1 dot by 2, so it becomes minus x1 dot by 4 minus x2 dot by 4. We know the value of x1 dot and x2 dot, which is VA and VB. I get y2 dot minus 1.5 meters per second, the velocity of this load. It is moving in the upward direction as they are moving in the outward direction, in the opposite towards the right direction. I take this one is positive, so therefore the load velocity is in the negative direction. In the similar way, you can find the accelerations. The problem 2-2-15, the pulley system of the previous problem is modified as shown with the conditions of a fourth pulley, right, and a third cylinder C. Determine the relationship which governs the velocity of the 3 cylinders and state the number of degree of freedom. Express all velocities as positive shown. Now we put another pulley. If you see, this is the first rope, this is 1, and this is the second rope, 2. So number of cylinders is not determining the degree of freedom. Number of ropes are basically determining the degree of freedom. So it's a 2 degree of freedom system. We need to find the velocity of A, B and C. This is the system basically. If you see very clear, this is, I say y, this is YB, this is YC, this is YA, and this is the interpreted pulley which is moving, I say it's Y1. So we put another pulley, sorry. This is like this. This is a 1 and 2, So it is three bodies, so there is a 3 degree of freedom, right? So this is YA plus 2Y1 plus some constant is equal to L1. Clear? The next one is YC, this is YC, right? YC plus YB, and this is minus Y1, right? This distance is because it can move from only here to here, right? So this rope, this is YB plus YC, and this distance is minus because this pulley can move up to here. Minus Y1 is equal to L2. So now take the derivative. Y dot A plus 2 Y1 dot is equal to 0. This is equation number 3. This is 1, this is 2, and this is 3. The third one, YA dot plus 2Y1 is equal to 3. This next velocity, I take this derivative. YC dot plus 2Y dot B is minus Y1 dot is equal to 0. Y1 dot is the intermediate velocity of this pulley. So therefore it should be eliminated. So I multiply this equation and add these two equations. Y1 dot is being eliminated. And we get Y1 dot plus 4Y dot B plus 2Y dot C is equal to 0. VA plus 4 times VB plus 2VC is equal to 0. The next problem is 2-2-16. Neglect the diameters of the small pulleys and establish the relationship between the velocity of A and the velocity of B for the given value of phi. If you see, this is the body A moving within the guides. This is the body B which is moving freely in the vertical direction. We want to develop the relationship between A and B, velocity of A and B. This distance is B, this distance is B. Let's see how many degree of freedom. If you see, this is one rope, and therefore it is 1 degree of freedom. I took this with Y, this is B, this is given your equation, right? So this is Y, this is X, this is B. Now, length of the cable. Length of the cable is 2x, of course, plus 3 times of this. 3 times of this. 3 times of what is this? Y square plus B square under root 2 plus 1. Now simple differentiate it now with respect to time. The 2x dot plus 3 half y square plus b square 2y dot, and the x dot is the velocity of A and y dot is the velocity of B. So 2vb plus 3y va under root v square y square plus b square is equal to 0. Vb is equal to minus 3y over under root y square plus b square to va. That is your relationship between B and A. If you know the value of y and B and one of the velocity of the body, you can find the second velocity. Next problem is 2-2-7. Determine the expression for the velocity of VA of the cart A down decline in terms of the upward velocity VB of the cylinder. It is moving. The cart is moving in the downward direction, and this load, the cylinder, is moving in the upward direction. This height is x. This length is x. Right, and this is this is one rope, so 1 degree of freedom, right? 1 degree of freedom. So I have done the same equation. This is x, right? So L is equal to, what is this? X square plus h square plus 2y is equal to constant. Now let's take the derivative. This is 0. It is half x square plus h square minus half 2x x dot y h derivative h is 0 plus 2y dot. So I can simply simplify it. X VA over under root x square plus h square plus 2 VB is equal to 0. VA is equal to minus 2 VB under root x square plus h square x. If I know the value of x, h and VB, I can find the VA. And if I know the value of x, h and VA, I can find the value of VB. Problem 2-2-21. Collar A and B slides along the fixed right angle rods and are connected by a cord of length L. Determine the acceleration AX of collar B. Right, collar B, it is moving forward and backward, it is moving upward and downward. So we need to find the acceleration of collar B along the x as a function of y if collar A is given a constant upward velocity VA. So it is moving in the upward direction, right? So very simple, because this is x, this is y, to x square plus y square is equal to l square. So I take the derivative 2x dot plus 2y dot is equal to 0. X dot plus y dot is equal to 0. If we take the second derivative, again we use u into y. So if I say x double dot plus x dot to become x dot square. So it is y double dot. Similarly, I can put the y dot into y dot square. As the y double dot is 0 because the VA is constant upward, so therefore this equation is xab plus x dot square plus y dot square is equal to 0. Y dot is the velocity of A. Ax is equal to basically the acceleration of B. So the acceleration of B, just to collect the terms, it becomes minus x dot square plus y dot square by x, and AB is equal to, if I need to find the acceleration of B, minus, because we know here x dot is equal to y by x times y dot from here. X dot is equal to y dot by x. So we put the value here just to simplify, taking the common, simplify, and we get this. Now here we also know that the x square plus 1 plus y square x square is equal to L square from here. So I put the value here, further simplify, find the AB, minus L square or L square minus y square by 3 by 2 VA. If VA is known, L is known, y is known, I can find of course the acceleration of B. Thank you very much, the students. I have in this lecture completed the constraint motion, 1 degree of freedom, 2 degree of freedom, and solved number of problems 6 to 7. Please go through this. Why I solved the more problems in this, because the students do not realize how to find a degree of freedom and how to select the lengths which are going to be varied. So therefore I have solved a number of type of problems to help you in this regard. Inshallah, we start chapter number 3, the kinetics. That is easy, because you should know the simple rectilinear motion, curvilinear motion in Cartesian coordinates, in anti-coordinates, in polar coordinates, right? So we only put the F is equal to MA. This A may be in Cartesian coordinate, it may be normal tangent coordinate, it may be r theta coordinates. So this becomes easy for you in the next. Only the force will come in this next in kinematics, because in kinematics we study the effect which produce that particular velocity, displacement and acceleration. Thank you.